Welcome everybody, my name is George Castro. Today I'm going to talk about infrastructure, more specifically cloud native infrastructure, and how we see things happening in the infrastructure space in cloud native. I work for the Cloud Native Computing Foundation, which is a nonprofit that organizes open source. It's a part of the Linux Foundation, and I practiced this talk so many times and it always ends up too short. So I'm purposely trying to slow down. I tend to get excited when I'm talking about this kind of stuff. A little bit about me. I'm based in Ann Arbor, Michigan. I've been in infrastructure probably for the last decade. Army vet, I got into technology at a company called SAIC. Then I worked on Ubuntu for about a decade. So if you've ever Googled a problem with an Ubuntu instance, you might find my face there on Google when you search for that. Did Kubernetes for a while for a company called Heptio that got acquired by VMware. Did VC for a little bit. And then now I work for the CNCF. Today I'm going to talk about how cloud native has become kind of the backbone for AI infrastructure and some of the things that we are seeing in the industry as far as adoption, what tools people are using, and what lessons they're being learned, and how we can basically take our open source patterns that we've learned from over the past 20 years and apply those not only to the infrastructure but to the workloads themselves so that we can use the stuff to do what our customers want, which is build great products and add value. So that is the CNCF. Over the past few years, we've been doing a lot of analytics and analysis on the expansion of the market, and it's going to continue to grow over the next few years. I don't think this slide should surprise anyone at the amount of value that we see in the AI market over the next few years. One of the things that we found very interesting is how cloud native was one of the springboards that allowed AI to scale. Due to its very nature, AI is very scale intensive. You can't really just kind of sort of do it. As a result of this, the companies that have chosen and already kind of invested in cloud native infrastructure were able to basically take those advantages and then apply that to the workload. So here we have two examples, the Australian Institute for Machine Learning, which uses a few of these components. These are projects that are within the CNCF, the Cloud Native Computing Foundation. And the way we work is we're kind of an umbrella organization that hosts a bunch of projects. It started off with Kubernetes in 2016 and has now branched to over 200 projects. So these are components you might have heard of. Obviously Kubernetes we kind of consider like our Linux kernel for distributed systems. It's the thing that the ecosystem kind of was built around. However, as we've gone into our second decade, Kubernetes just turned 10 this June, makes me feel really old. So as we go into that next decade, we are starting to see that ecosystem of cloud native tools that were built around Kubernetes are also starting to generate their own ecosystems. And some might not even directly need Kubernetes, but they're cloud native nonetheless. So Kata is I'll start with Kubernetes, which is the cluster, the thing, you kind of have to have it. This one, there's a talk on OpenAI at KubeCon where they outlined how they use Kubernetes for training for OpenAI. This is very interesting because if you invested in Kubernetes early, it was easier for many of these startups and other companies to ingest and get into AI because their infrastructure was already in place. You couldn't really say, hey, let's get into AI and then not have the infrastructure in place. You were already at a disadvantage. So the organizations that took advantage of cloud native, knew how to scale, had learned how to use the software, had learned how to do cross regions and multiple data centers and all that stuff, were really the ones that were primed to really take advantage of Gen AI on top of Kubernetes. An example organization that I would use for that would be Adobe, that was a Kubernetes shop beforehand. So Kata is an interesting one that they use. That is an autoscaler, and it's become kind of a necessity these days at the level of scale that we're talking about. And then Karmata, which is an interesting one. I almost call it a Kubernetes for Kubernetes. that's designed to do orchestration across multiple clusters. So it kind of, the joke we like to say is it's turtles all the way down. It's just more turtles there to orchestrate with. Kubeflow is an interesting one. This one kind of predates the Gen AI trends that you've been seeing recently. It's kind of, I call it the OG old guard of machine learning. It's been around for quite a while, and it's actually 5 separate components that make up Kubeflow. And that has been doing machine learning in production in Kubernetes for years now. So that's become a critical component to many companies as well for deploying those workloads. And I like to put Volcano on your radar, which is a batch project that is getting a lot of attention recently. So over the years, we've been collecting infrastructure projects, and over the past few years especially, as the industry has started to adopt these common patterns, you're starting to see more and more associated tools coming into our space. Because how many of you are familiar with open source at all? Or not? Okay. We're all probably using it, whether you know it or not. But the organizations that learn to take advantage of open source and invest in it really kind of end up with a long-term strategy on how to ingest the stuff when it comes to their infrastructure. A lot of organizations, when it comes to this level of scalability that they need, when they make these technical decisions, you're kind of stuck with it for 10 years, right? So for many of these companies, it's an investment into their infrastructure needs, not only at today, but the ones that they don't even know they had. Many of the companies that were investing in Kubernetes earlier ended up in Gen AI in really good spots because they got their infrastructure ready before the workload came into being. And CNCF projects are leveraging AI as well. This one's interesting. It's called KGPT. It actually connects to your cluster and it helps you administer your cluster using Gen AI. This is very interesting because, especially in the early days when tooling wasn't as mature, the kind of joke was how difficult it was to administer Kubernetes clusters. So now we can have the tail wagging the dog as well. So that is another CNCF project that might be interesting to you, especially to your cluster operators. TIKV is one that I'm going to talk about. You might have heard everyone talking about TiDB a lot today. And if you go back to this other slide, you came to see a talk about Gen AI, but all this stuff here on the right is infrastructure software, right? It's not directly doing Gen AI. It's helping. And TIKV, similar for TiDB, is a similar kind of project. What's really interesting about TIKV is that it was donated to the CNCF. And when a project is donated to the CNCF, the trademark, the domain, and everything is kind of put in the community's goodwill. This is very important, especially in the past few years when sometimes vendors do change licenses, right? And as you can see, sometimes people like that or they may not like that. So when an organization does take the time to donate a project to the public good, it kind of gives other organizations that level of confidence that they're looking for, that this will always be open and there won't be any rug pulls under there. So TIKV is in the CNCF, and definitely want you to check it out. Also, another important component that has nothing to do with generative AI, except you need a key value store that can scale, right? So that's an interesting component, and that's what brings me here today, actually, because what we do is, it is our job to ensure that these projects remain healthy and that users see the value. There are end user organizations that come to the CNCF saying, hey, what do we use? Because we do have over 200 projects, and it's like a big buffet, right? And just like a real buffet, just because you can go and grab a plate and put whatever you want on the plate doesn't necessarily mean that entire meal will be appetizing, right? If you just randomly grab stuff, things won't work. But when you put things in a certain combination, that can certainly solve problems for folks. and it can help platform teams build great products. All right. But there are challenges ahead. Kubernetes itself wasn't really designed for AI. It was designed to solve a problem, which was, at the time, how do we scale these applications in around 2016? Web apps, usually, right? It's like we have a store and it needs to scale on every continent, that kind of thing. So over the past few years, Kubernetes itself has had to innovate internally and to be able to become more flexible in running these workloads, especially at scale. And of course, we have to take all of the things into consideration. So one of the great things about Kubernetes, one of the reasons that it was so widely adopted is it's API driven, right? And one of the great things about it being API driven is it's a common substrate across all the clouds and on bare metal. That means if you're building a platform, it's generally easier, and I put that in quotes on purpose, to build those platforms using Kubernetes and cloud native APIs that you can use on any cloud and on bare metal and at scale. So how do we allow AI workloads to run on Kubernetes, but then give those developers the same kind of API primitives that they enjoy using in that kind of Kubernetes style? Of course, when I did say that, easier, right, we do have to remember that this is distributed computing, and it is rather difficult to solve some of these problems, which is why it is important to us, and one of the reasons the CNCF was founded is when it comes to infrastructure, it's better when it's open source for a few reasons. It's easier to kind of monetize, and it's easier to solve things together as a community. And the CNCF provides that vendor-neutral place where projects can collaborate on a common problem. And this leads to new users' experiences that people love. So this is how we're rising to the challenge. A few years ago, as the hardware vendors became more closely involved and Gen AI really started to explode, we started to partner with companies that are working in these fields and collaborating all under an open source umbrella, vendor neutral as always, to ensure that Kubernetes is good to go when it comes to these workloads. So this includes the hardware manufacturers, the software companies, and pretty much, if you can imagine, everyone in tech started to show up to these meetings. All the meetings are public and are on YouTube and are open to anyone, of course, as you would expect in an open source thing. So dynamic resource allocation is becoming way more sophisticated. In the old days, if a workload needed a GPU, you gave it the GPU and it got the whole GPU. Now with dynamic resource allocation, it's become easier to slice and dice those across the cluster so that it is more efficient and we can pack more workloads into a cluster than ever before. This took a tremendous amount of engineering work and has landed. Kubernetes 1.29 and newer is what you're looking for if you're looking to deploy GPU accelerated clusters. Cool little bit of trivia is each Kubernetes release has its own like stylized logo here. This is an Indian pattern that has a bunch of little, it's got a bunch of little Easter eggs in there if you're ever interested in checking it out. So yeah, 129 and newer is what you're looking for that. And I'd like to introduce you to the AI engineer, which becomes a half, well, not half, I guess you're part ML researcher and scientist. You're an engineer, you're an AI engineer, but you're also a full stack engineer. You got to know the platform and all this kind of stuff. And you have to know how to translate that into APIs. So this is kind of a role that didn't really exist before. This is starting to become a pattern that we're seeing more, where it's great if you know ML or AI, but wow, it really does help if you know the platform engineering side and the platform itself in order to extract the most amount of performance out of the cluster. Quick history of Gen AI. I know I did not know it went this far back, actually, until a coworker gave me this slide. And I thought we started over here, because I remember natural language processing and things like that. So I'm not going to go over every one of these steps, but it's just an important thing to remind. It's kind of interesting now that we're here at the Computer History Museum, is to understand how everything old is new again and everything new is old again. So as I was starting to research each of these points, it became more apparent to me how we build the future on the things that came before. And I thought that was very interesting because before Gen AI, cloud native was kind of the big thing that people were talking about, right? And it's like when a new thing comes out, is this a thing that's going to replace the old thing? But as it happens, adapting the workload on top of the thing that runs the workload ended up being the right solution for everybody. I'm assuming a lot of you, how many of you are using LLMs regularly for stuff? Probably way more advanced than me. Okay. This slide is probably kindergarten to you, but usually we try to cover all the bases. So LLM's great for generating content. I use it all the time to rewrite my awful English into something that's more readable, and then slice it and dice it in different ways. And we use it a lot actually internally at the Linux Foundation to do things like generating content for certification exams and all sorts of interesting things. But as many of you know, probably know more than me, is you got to take the good with the bad and then figure out your middle sweet spot there when it comes to exactly how you're using LLMs and things like that. I'm sure you've seen all the funny things on the internet that people ask LLMs and they get confused about. And now I kind of want to talk about the next trillion core hours, because there was a point in time where Kubernetes in the community, we kind of had to figure out how we're going to handle generative AI workloads and the subsequent innovation that comes along with technology like that. So first things first is hardware enablement. I talked about a little bit about that. And even though dynamic resource allocation is a thing, there are other parts of Kubernetes that had to be touched down to the deep engineering levels that had to happen. So, even though it's easy to just say GPUs, there is a ton of hardware out there that needs to be enabled, that is out in the field, that needs to be accounted for. So a lot of effort has been taken in that area to make sure that that is rocking and rolling. Workflow enablement is a thing, even though the cluster might be capable of doing the stuff. It's kind of useless if people don't know how to put their workloads on the cluster, right? So there was a significant amount of effort in multiple projects to ensure that those workloads get on the cluster and run more efficiently. And as you can imagine, a lot of that is being aware of what hardware is on the node to begin with that your workload can use. Index jobs. This landed actually in Kubernetes 1.24. When I was starting to put this slide deck together, I was surprised actually on how much of this stuff was actually done years earlier. It just isn't obvious to you unless you're tracking all of the things. And then you get to the end and kind of wrap it all together to realize the overall improvements that Kubernetes has made to run Gen AI workloads. So you can now reorder jobs and stuff like that for efficiency, which is great. And job tracking is a big one. This is what allows CERN to do over 100,000 concurrent pods on a cluster. And those are numbers that most organizations will never need to reach, but I don't know, every time I say something like that, someone does something and there's like way more zeros at the end. So it never ceases to amaze me here. I'd like to show you two batch systems here. Some of my coworkers used to do high-performance computing at the University of Michigan, and the amount of innovation in this area alone around batch compute and all that stuff is a subject for its own talk that I'm encouraging them to submit at some point. I talked about Volcano earlier before. That project is definitely getting a lot of traction and is becoming very active. And also Q with a K, of course, because that's our thing. And we actually have 2 separate batch working groups for people to be involved. One at the cluster level at Kubernetes, and then one at the CNCF level if you want to consume all of the things. So be cognizant of that. So application development, just facilitating the development and deployment of AI applications. This sounds so easy, right? It's like you read this bullet and you're like, of course you want to do that. You wouldn't make that complicated, right? But where we were to where we are going now has evolved a lot of people there. So for Kubernetes as a project, you kind of have to sit there and say, how are we going to handle this? So another one, Kubeflow 1.8 is coming out, I don't know, any minute now, or it might be just out. This is a major release of Kubeflow. That project continues to gain adoption. It recently has moved into the CNCF over the past year. Before that was a Google open source project, and it took a while to kind of move, a lot of paperwork, to move it under the CNCF, so that's all good to go. And Karmad is another one of those multi-cluster projects that helps you manage multiple clusters. And as you can see, sometimes I might mention projects and there's overlap, right? And sometimes it looks like some projects might be competing with each other, and sometimes they are. Usually the CNCF are very hands-off, and we don't do like a top-down approach, like, okay, you're going to be the official queuing thing, and you are not. Like we don't really do that kind of stuff. What we do see ourselves as kind of stewards of an ecosystem, and then we let the organisms kind of find their places in the ecosystem. And then the users and producers every organism finds its spot in the ecosystem eventually. KubeEdge, which has multiple components, has one called Sedna that might be interesting to you. And that's doing, pushing the AI workload all the way to the edge nodes. This one I just recently discovered, and fortunately I don't know much about it, but it's on my to-do list. So I'm just here to tell you that exists. So that's how we're kind of looking at improving the application deployment on top of the cluster. Ollama, got to work with those folks a little bit when they get to KubeCon. And a lot of our tools are just starting to naturally grow endpoints to other open source tools. So 6 months after Ollama became a thing, all of a sudden you started to see Ollama integration points with a bunch of CNCF projects. And that's what we like to see. We like to see all of these projects working together so you can connect them together and build whatever it is you're building. OPA? Oh yeah, I'll get to that in a second. All right, so first of all, Caverno and OPA are policy management tools. That's the thing that you run on a cluster. So when George says, I need a database with like 300 CPUs, it says, no, you're not allowed to do that on this cluster. I'm sorry. And then it like sends you an error. So Caverno and OPA are used for lots of things. Policy enforcement, and that covers security, cost optimization, ensuring that the right workload is on the right cluster so that it's matched with the right instance type, and all sorts of things. Both of these are CNCF projects. OCI in this context, it does not mean Oracle Cloud Infrastructure, although that is a use of that term. I just came from Oracle Open World, by the way. That means the Open Container Initiative. Wow, I had to think about that one for a second. When you do a Docker pull or a Podman pull, that pulls down an OCI blob from a registry. And that open container is an open spec that was donated by Docker in 2016. I think I might have painted myself in a corner in the past. So that is an open spec, and that is the reason. That's one of the significant reasons why containers are so useful and why, like, you can't build Kubernetes without having a standard like OCI. So that's the blob and specification. There's like metadata. So when you grab a tool written by somebody else and you run it to inspect a Docker container, and that totally works magically. It's because of things like the OCI spec. So this is a question I kind of had, is like, what's the relationship between OCI artifacts and LLMs, registries, and object stores? Because as I started to learn OLAMA, you're doing the same things I was doing with Docker. I'm pulling, I'm updating, I'm pushing a thing. So these are sort of some of the questions, like where should these live in registries, object stores, that kind of thing. Everyone got a picture of that one? I saw a lot of people wanting that picture. So fundamentally, I want you to learn one thing about what Cloud Native is doing in the space for Gen AI, and that is about unlocking new primitives. So trying to give those same API-driven things for your platform teams to drive is the general case. And I like to bring up a quote here for inference is the new web app. Clayton Coleman is one of the original developers of Kubernetes. There's an awesome documentary on how Kubernetes was started on YouTube. Just history of Kubernetes and YouTube, and you know how to find it. And it talks about, I think Clayton was at Red Hat at the time, on what it was like back then to bring Kubernetes to market and, for distributed computing, which is very interesting because 10 years later, Coleman's on the stage and he says, inference is the new web app, because Kubernetes is kind of solved to like help make scale web apps, right? And then if you look at what people want to do with Gen AI, it's similar as in like, we want everything to just work and be scalable, and I want to click an up arrow and everything magically happens, but with a totally different workload. So this was kind of the moment where people realized that inference is actually our new web app. So this is the kind of mantra that Kubernetes is currently looking at for the next decade, which is, if inference is the new web app, then we're going to be the new web server, which is fantastic. So this is a very difficult problem. It's the scalability of these workloads, and it takes multiple organizations, so it's not just us at the Cloud Native Computing Foundation. There's an entire LFAI and data organization, and PyTorch is its own foundation, actually. So if you're a PyTorch nerd, they have their own events and things like that. So definitely recommend you check them out. And let's see. Yay, we could do it together. That's my happy slide. So one of the things I do want to mention before I start to close, see, I told you I talk too fast, is the importance of keeping these things open. We like to think of the infrastructure people like us, we're like invisible to the world, right? It's like when everything is working, no one knows we exist. But when one thing breaks, it's like all of a sudden everybody's a thing. But it is important to keep these tools and things like that open in a vendor-neutral place, because that's what allows innovation. And at the end of the day, open source kind of took over the entire world. And if we aren't doing our jobs, the modern world just doesn't function. There'll be zombies the next day. So when organizations take the time to ensure that these tools like TIKV remain open for us to use forever, that is a great thing that we should really thank people for, because these components, all of the stuff that we're talking about here wasn't possible without open source, right? Like, think how hard this would be without Linux. It'd probably be a lot more expensive. So that's kind of the mantra I want to leave you with here today, was when it comes to organizations like us, we're always striving to push the edge of the envelope and be technologists and ship as much stuff as, well, not as fast as possible, but ship the best stuff possible. And really for us, it's about leaving things better than we found them. So if you do get a chance to go to KubeCon, this year it's in Salt Lake City in November. You can always just type KubeCon into your search engine and it will come up. And there are there's two major ones here, is the one in the US, Salt Lake City in November, and then next spring in London in England. And then this year, I just came from KubeCon China in Hong Kong, which was large. And then our first KubeCon India is happening this year. So definitely check that stuff out. We continue to grow The KubeCon in Paris, which was the last European one, was 12,000 people. It's the largest one ever. Just when I think we've reached peak Kubernetes, someone adds more zeros. And in the case of Gen AI, they added a lot more zeros. So I'm going to leave you here with some information here today. There's the CNCF AI working group, which is probably where I would send you first if you're like, I'm really interested in this stuff. I want to find out where all these projects are. There, you can definitely do that. And like I said, all of the meetings for all of our projects are public. Most of them at a minimum have at least a monthly meeting. Most of them take pretty good notes that are published regularly. And a lot of these projects also publish regular status reports, health status reports, and things like that. And at the CNCF, we're working on ensuring that these projects do have the resources that they need to remain healthy. And at some point over the next year or so, you'll be able to go into these projects, click on the logo, and then be able to see who's contributing, what affiliations, and kind of give you that. You ever look at a project and you say, okay, my boss wants me to look at this thing, and then you go and you have to dig through GitHub and figure out, it's like, okay, who's using this? Is this actually any good? It says it's open source, but is it really? What license is it under? You know, what's the history? You find yourself spelunking in GitHub sometimes, which is fun, but not after the 10th time. So we're working on a series of dashboards and things like that for all of these projects, so you'll be able to look at what parts of the buffet might be more palatable to your taste. And then, as always, we're on the Slack. CNCF Slack is, and the Kubernetes Slack, one of the largest in the world. There's 190,000 people in the Kubernetes Slack, just to give you a sense of scale. And of course, mailing lists, because those will never die. Thank you.